Now we're going to do calculations using sig figs. So we have two basic operations that we're going to talk about, multiplication and division, as well as addition and subtraction. So multiplication and division, really straightforward. You'll like this rule. The number of significant figures in the answer is going to be the same as the value within the fewest sig figs, as the value with the fewest sig figs in the problem. Let me show you an example of this. So take a look at this problem right here. I'm going to count sig figs. Notice I did it in scientific notation. I wanted to point out the scientific notation is just a placeholder. So you don't have to worry about that 10 to the 6 when you're counting sig figs. You just look at this number right here. So we are going to have 1, 2, 3 sig figs. 3 sig figs. Down here, be careful, a little tricky. This has 2 sig figs because there's no decimal. If there had been a decimal, it would have been 3. So this has 2 sig figs. So you divide this, put it in your calculator, and the answer is 7,035. So to determine sig figs for this, you go to the number that has fewest sig figs, right there, 2 sig figs. So what I do is I draw a line. I go 1, 2, draw a line. And then you always look to see if you need to round. So I say this is truncating, and I think, does a 3 make it round? No. So the answer is 7,000. Now this is tricky. If I put a decimal right there, it looks like 4 sig figs, but that's not the answer. If I put a decimal right here, that's 70. That's not the answer. So the way to represent sig figs, the most accurate way always, is scientific notation. The way I'd represent 7,000 with 2 sig figs is 7.0 times 10 to the 3. You see 1, 2, exactly 2 sig figs, and the place value is to the thousandths place. So cool. Now, adding and subtracting on this operation, I'll tell you right now, the definition is clunky. Once I show it to you, you'll be okay with it, but the definition is cumbersome. Here we go. The number of decimal places in the answer is equal to the number of decimal places in the value with the fewest digits in the problem. Okay, here's the key. And you want to put a star in your homework, in your notes, to remember this. I've done this for years and years and years, more years than I want to admit. I still do this. Put a star. Line up the decimals. Line up the decimals. And what you're going to do is truncate at the fewest digits. So I can see 10.601 goes out to the thousandths place, 4.2 goes out to the tenths place. You draw a line at that fewest digit, the least digit, which is going to be that 4.2. Now, if we go ahead and add this, 108.41, everything on the left-hand side of that line, that's going to be your significant figure. Now, I want to drive something home that's really important. The number of sig figs in those two values in the problem don't impact this number down here. Not like up here. With multiplication and division, you have to count sig figs. Down here, you line up decimals for adding and subtracting. Notice the top number has 5 sig figs. The second number has 2 sig figs. And our answer, see, I'm not going around, is 14.83 sig figs, 3 sig figs. So that's how you do significant figures for multiplication, division, adding, and subtracting. Now, what if you mix these two? Look at this problem right here. We are changing operations. Now, you know order of operations. We always do addition and subtraction, so the parentheses first, and then you do multiplication and division. If you change operations, you have to truncate, do the sig fig here, and then you carry that value in the rest of the calculation. Now, if you don't change operations, and especially in chemistry, you could have 5 conversions in a row. So you're multiplying, dividing, all multiplication and division. You don't truncate, you don't cut off for the sig fig until the very end. You carry all those numbers until the very end. Then you just find the smallest sig fig and report the answer to the smallest number of sig figs. It's when you change operations. So this is a type of operation, multiplication, division. This is a type of operation, adding and subtracting. When you change operations, you have to truncate. So let's look at this one together. we are going to have our addition, 32.76 plus the 9.2. I'm going to do just this part so you can see me truncate it down here. We're going to have the 32.76 plus, now so important, I line up the decimals, 9.2, 9.2. Add this, we get 69.41. Okay, so there we have it. I find the least digit is at the tens place, and that's where I truncate. Now take a second, and I'm going to round. So when I round this, it becomes 42.0. That's the number I carry. I'm not going to carry the 41.96. I carry the 42. So up here is actually going to be 76 times 42.0. Then I divide it by the 0.1234 times 10 to the negative 2. Now I'm going to write down the calculator dump. So I did this in my computer, my calculator. I'm going to write down every digit the calculator showed me. It gave us 2586709.887. And by the way, never write a calculator dump anywhere. Never write a calculator dump. It will infuriate your science teacher. Always do your best with sig figs. Okay, so I have my number. We did a great job truncating when we added and changed the operation to multiplication. I have to go back and count sig figs. So we have 1, 2 sig figs, 1, 2, 3 sig figs, 1, 2, 3, 4 sig figs. So the smallest number of sig figs in the problem is 2, which means I'm going to have 1, 2 sig figs here, draw that line to truncate it, take a second to see if we need to round. We do. We're going to round up. So we are going to get 2, 6, 1, 2, 3, 4, 5. So we are going to get 2,600,000. Now remember, the accurate way to represent this is with scientific notation. Now technically, by not putting the decimal there, yeah, it's 2 sig figs. But it's always best to use scientific notation. Our answer then is going to be, let me erase this. Let's see here. It will be 2.6 times 10 to the 6. And you can clearly see 2 significant figures. So that's how you do calculations using significant figures. Thanks.